Hi everybody, today we're going to be talking about the inverses of logarithmic functions. So to begin, it's important to understand that logarithmic functions have an inverse that are exponential functions and vice versa, which you can see on this graph here. They are reflected over the y equals x line. So as you can see here, this is what a logarithm looks like. And if we were to do the inverse of this, so if we made this a function equaling f of x, we're going to find the inverse. So this can be done by first making this a y, and then changing around the x and the y, which you probably learned in Geometry or Algebra 2, the ways to find the inverse of a function. And by the basic definition of logarithm, we are going to raise the base to the power of x. That's going to give us y. So that would be how a logarithmic function is an inverse of an exponential function. Now we have some different examples here to further understand how to find the inverse of a logarithmic or exponential function. The first one states f of x equals log with the base 2 x minus 3 quantity minus 5. So in order to find the inverse of a function, the first thing you want to do is make the f of x a y and rewrite the equation. Then you're going to exchange the x and the y. So you're going to make the y the x and the x the y, as shown here. And then you want to solve for the y. And in this case, we are going to add 5 onto the side. X plus 5 equals log base 2 y minus 3. And then we are going to rewrite this using an exponent. So we're going to raise 2 from right here to x plus 5. And that is going to equal y minus 3. Since we want the y by itself, we're going to subtract 3 to the other side and get 2 with the x to the 5th power plus 3 equals y. And if we want to write that as a function, we would say f to the inverse of x equals 2 raised to the x plus 5th power plus 3. Our next example states f of x equals the negative natural log of 1 minus 2x plus 1. So like we did in the last video, we are going to change the f of x to be y. Then in the next step, we are going to exchange the y with the x. And now we are going to try to isolate the y. And first we are going to subtract this positive 1 onto the other side, and we're going to get x minus 1 equals negative natural log of 1 minus y. Now we can't yet raise e to the x to the minus 1 power. We first need to get rid of the negative right here. So we will divide this whole thing by negative 1, and that will give us 1 minus x equals the natural log of 1 minus 2y. And then we are going to raise e to the 1 minus x power, and that's going to equal 1 minus 2y. From there, we are going to subtract 1 onto the other side and divide by negative 2, which is going to give us y equals negative 1/2 times e to the 1 minus x minus 1. And if you want to distribute the negative 1/2, you would get y equals negative 1/2 e to the 1 minus x plus 1/2. And of course, we want to rewrite that so that we have an inverse function, and that is as shown here. Our next example states that f of x equals 2 multiplied to 3 with 3 to the x as a power minus 1. So we're going to replace f of x with y, and then we are going to change the y and the x. Then, just like we did in the last problem, we want to isolate the y, so we will add 1 to both sides and get x plus 1 equals 2 times 3 to the 3y power. And then we are going to divide the entire thing by 2, and that will give us x plus 1 divided by 2 equals 3 to the 3y power. And right now, this is written as an exponential function. We are going to change it into a logarithmic function by taking the log with base 3 to the x plus 1 divided by 2. And that's going to equal 3y. Then we're going to divide the entire thing by 3, and another way to do this would be to multiply by 1/3, which is what we're going to do because it looks a little cleaner. So we're going to say 1/3 times log base 3 of x plus 1 over 2. And to rewrite that as a function, we would say the inverse is equal to log with base 3 to the 3rd power of x plus 1 divided by 2. And I know these are written two different ways. They can actually both be written as functions if we add the inverse here. Either one of them is an acceptable answer. And our last example deals with natural logs again, so we're going to have the f of x equals 1 minus 2e to the negative 2x power, and we are going to rewrite that with a y here. And then we are going to exchange the y and the x. So we'll have x equals 1 minus 2e to the negative 2y power. And then we're going to subtract 1 from both sides, and we will get x minus 1 equals negative 2e to the negative 2y, and divide by negative 2. So that will give us x minus 1 divided by negative 2 equals e to the negative 2y power. Then we are going to take the natural log, so we're going to say ln, which has base of e, but that's not necessary to write in, of x minus 1 divided by negative 2 is equal to negative 2y. And then we're going to divide the entire thing by negative 2, and another way to write this would be the negative 1/2 of the natural log x minus 1 over negative 2. And that's going to give us a y, and we can rewrite this to be a function and say the inverse equals the negative natural log of the square root of x minus 1 divided by negative 2. And you would get that from raising this to the negative 1/2 power, which is known by your property of logarithms.